So we have our slope, or we don't have a slope here. So I asked you to find P and, oops, I gave the wrong things. That might be why you were struggling to find it. How about I ask you to find P and J? Or S and J, well that's J and this is now 7. Does that make it easier to do? So now we have this triangle right here. Do we know this height here? What is it? 8'9". Yep. The 9'3" minus 6 inches. So 8'9", otherwise known as 105 inches. Or 8.75 feet. 8.75 feet is the version I would most likely use. How does that help us? Well, that helps us find this. First of all, yeah, the 8'9" is just the 9'3" minus the 6-inch heel. Let's label this A. How do I find A? Over A. So that is 105 divided by 7, otherwise known as 35. No. What is 105 divided by 7? 15. This is 15, so that means S is 30 feet. How do we find J? J, of course, is the top chord length here, including overhang. Careful. You're looking at this triangle here. So you're right on the 16. We need to find a new height here because the height only went down to here, and we're going all the way down to here. I'll call this B over 16. So 7 times 16 is 112. Divided by 12 is 9 1/3. Right? Yep. So that's 9 1/3. So now it's that squared, so we're going to second square it. Second answer squared plus the 16 squared equals 18.52. 523, we're going to call it feet. So of course, that is 18 feet. Subtract 18 times 12, 6 inches. Subtract the 6 times 16. 4.46 is 4/16 or 1/4 inch. So 18 feet, 6 1/4 inches is J. Not so bad?
Not so bad.
Yeah, once I gave you the right stuff. It wasn't impossible, it was just very improbable.
Well, when it's not even on the scale. That's great.
Got her? Down here? This one? You had 15 here plus the 1 foot overhang. How about attic trusses? An attic truss has framing built in for a room in the attic. A lot of things about attic trusses. One is the bottom of this truss basically is just a beam because there's not a lot of webs. What gives a truss a strength, and we've just been looking at simple triangles. What really gives a truss a strength is it has webbing in it. Usually something like that. If it's less than 30 feet, it can have a W web like that. If it's more than 30 feet, it has to have more webs. It's that webbing that takes the force, it takes the load that's pushing down here, and it transfers it along the axial. Same here, it takes the load that's pushing down here, and it transfers it like that. So the forces get all transferred and it holds up. That's what gives it its strength, is this webbing. The attic truss, because it has to have this room open in here, has a noticeable lack of webbing. So it must have, I mean, it can have, a lot of times we'll have webbing like right here, you know, maybe a web like that and that, and possibly either a single web there, or if it's a big enough truss, it might have a W web on top like that. Medium-sized truss, have a wishbone web like that. So there's all sorts of opportunity. Those sections that are outside the room are structural. The webbing is structural. So we have basically 3 weak spots. One weak spot is this right here. No webbing to touch it. And then we've got these weak spots here. So we have to make sure those are big enough. Typically the top chord of an attic truss is at least a 2x6, often a 2x8. And the bottom chord is always at least a 2x8, if not a 2x10 or 2x12. If this room is less than 10 feet, generally a 2x8 is used. If it's more than 10 feet, you got to get larger. Well, 10 feet or more, you have to get larger.
No, that's just an attic truss?
That's just an attic trusses. Other trusses you can make, I mean, I've seen trusses up to 40 feet long and be 2x4 top and bottom chord. The only real exception is a lot of times you have like a scissors truss, which is like this. A lot of times we make that bottom chord 2x6, and the only reason they make it 2x6, it's not required structurally. It's because when you go to do vaulted ceilings, those scissors trusses are really hard to get perfectly straight. And when you got a flat bottom, it's really easy to get. The flat part is always flat, period. But when they're building these trusses, a lot of times, if that truss looks like that, well, the next one might be a little off. The next one might be a little off the other way. So they do 2x6 bottom chords, so that if you have to trim them to make the sheetrock, to keep the sheetrock from bulging, usually they have 1 inch to 1.5 inches that you're allowed to trim off those bottom chords. Normally they say never ever take a saw to a truss. That's the exception. And of course, then the tails, the overhangs can be cut off too. So you have to have large members on each of those two spots and on bottom. The other big thing with an attic truss is they never ever want you, like you've got these 2x8 cord, 2x8, 2x10, whatever. They never ever want you to splice in the middle of this room. Can anybody think of why? Kind of. There's two big reasons. When you get into lumber like 2x8 and 2x10, all wood does what as it gets older? Shrinks. It shrinks. You get into lumber that's 2x8 or 2x10, it may start out, like 2x8 may start out 7.5 inches. Have you ever seen a 2x8 that's 7.5 inches? No, most of them are what? 7 1/4. Problem is, depending on how wet it is when they're cut, I've seen 2x8s that shrink to 7 1/8. Actually, I've seen them shrink. Treated ones shrink to 6 7/8. Mm-hmm. And I've seen some of them end up at 7 3/8. In a normal attic, that makes no difference. It really doesn't matter. But when there's a room up there, you got a 1/4 inch difference between those as they shrink. What's going to happen to your floor? It's going to wobble or creak or whatever. It's going to do bad things, put it that way. The other thing is often when they put these together, it's metal plates that hold them together. And often they have metal plates that may extend slightly off the edge of the wood. That would be a bad thing. So in our attic truss, we've got some additional dimensions to deal with. Let's say normally an attic truss is at least an 8/12 slope. I've seen some that are 6/12, not very common. Usually it's 8/12 or steeper. If a 6/12 is going to have a really high heel height. So right now where I'm starting out is not very practical because I have no heels on this. But let's say we have an 8/12 slope. We have a 40-foot span. I want this wall here to be 7 feet. Find out what my ceiling is going to be. Find out what X is going to be. Find out what J is going to be. And of course, H overall. I can find H right away really quickly. Not a big deal, right? I use that triangle right there. This is H. What's the bottom going to be? 20 feet. Half of my 40. And it's 8/12 slope. 8/12 equals H/20. 8 times 20 is 160. Divided by 12 is 13 1/3. So that means it has 13 foot 4 inches, right? For H. I can find X. Well, this is 7 and this is still 8/12. 7 over X. 12 times 7 is 84. Divided by 8. 10.5. So X is 10 foot 6 inches. What's C? $19 feet. How did I get that? Yeah, 40 minus the 10.5 twice. What's left? Say G. How do I find G? This is J right here, right? Perfect. 20 squared plus 13 1/3 squared. So the square root of 20 squared plus 13 1/3 squared equals 24.037. That's 24 feet. Minus 24 times 12 should give us 0 inches. And times 16 to get sixteenths is going to be 7.1, so 7/16. So 24 feet and 7/16 of an inch. What do you think? Not terrible? Yeah, I mean, it's really not. There are worse things you could do.
Oh, yeah,
To be exact, there are worse things you're going to do. Find for me in this problem X, C, and J. I shall pause. Okay, so where'd you start? 10/12 applied to what? 10/12 applied to what? Because to use the 10/12, I gotta have a triangle. There are two possible triangles. I'll use this one. How's that? So this is 10/12. What else do I know about that? That's 19. So 10/12 equals, I'm going to call this dimension here A. A over 19. So 10 times 19 divided by 12 is 95. So A is, how about divide by 12 and not divide by 2? It is 15.833. Otherwise known as 15 feet and 10 inches. So that's A. So what is the overall height of this truss? I didn't ask for it, but we'll do it anyway since we're here. It's 1510 plus 26. 26 is 2 foot 2 inches, right? It's 18 feet. So the height of this is 18 foot. Anybody get that? Anybody care?
I'm having trouble with the order of things and all this information.
Yeah.
I'm just getting.
The next place we can look is right here. Still using the 10/12. I know that this is X that I'm looking for down here. What do I know about this side? No, it's not 8. This side right here. It's 8 feet minus 2 foot 2 inches. Where did 2 foot 2 come from? 26. So that's actually 5 foot 10 inches. So we've got 10/12 equals 5 feet 10 inches of rise over X. So we've got 12 times 5 plus 10/12 divided by 10, otherwise known as 7. So X is 7 feet. Questions? Not yet? Okay. This is 7 feet. Of course, this is 7 feet. 7 and 7 make 14. So 38 minus 14 makes C 24 feet. Now, the mythical J. Find J. We know this is 10, 12. What else do we know?
19 on the bottom.
Not 19 on the bottom.
21.
21. Okay, the 2 foot. Yep. So we've got 10 over 12. Equals, I'm going to call this B here, since I haven't used the letter B yet, over 21. So 10 times 21 divided by 12. 17.5 is this. So then J is the square root of 17.5 squared plus 21 squared. $27.336. So it's 27 feet. Right, 27.336 is left times 12 is 4 inches. Subtract the 4 times 16, and we're going to 0.48, so 0.16. So it's 27 foot 4 inches. What do you think? Still very sharp stick in the eye?
Yeah, there's not. So for all these, you're pretty much focusing on the top end.
Pretty much, yeah. Most of it has to do with this slope.
Okay.
As long as you're given the slope.
Yeah, I've been looking at the everything else. I don't know why.
Yeah.
But sure, absolutely. Let's throw a few more shapes in there, and you just, I'm losing everything. I lose my mind.
How many of you on this packet were done up to number 60 like you were supposed to be? No? Okay. Here's what I'm going to do. I have cut you a little bit short on work time the last few classes. So we're going to go ahead and take our break a few minutes early here. And then I'm going to give you guys the last 20, 25 minutes to work on this packet. Because I really want you to be done. Right now, you should be done up to number 66 is what we're shooting for right now. Which means we just have dual slopes and porch trusses left. Then we'll do overhangs and hip roof surfaces. And this packet will be all done. And then it'll be time for a quiz and a test. Then we'll get into trig.